So we're going to look at an example of factoring a quadratic trinomial that looks a little different. So this has quadratic form. We have something squared minus a number times the same thing squared plus 40. So it kind of looks like ax squared plus bx plus c, right? It kind of looks like a standard form quadratic trinomial. So one thing that we can do to make this a little easier to work with is we're going to do what's called a substitution. So I'm going to let y equal x squared plus 3x. So that means everywhere I see this, we'll use a blue highlighter, that would make more sense. Everywhere I see x squared plus 3x, so here and here, I'm going to replace that with the letter y. So I'm going to get something squared minus 14 times something plus 40. Right, so just to rewrite that, right, that's going to be y squared minus 14y plus 40. So now this looks like a normal sort of trinomial quadratic. So if we go to factor, we want to multiply to 40 and add up to negative 14. So that's pretty easy, right? We want to use negative 10 and negative 4. And because there's no leading coefficient, right, there's a leading coefficient of 1 rather, right? There's a 1 in front of the y squared. We can jump right to our factoring groups, which are y minus 10 and y minus 4. Now great, that's great factoring, except for the fact that our problem started with x's and not y's. So we're going to go back through, and now where we see our y's, we're going to replace that with x squared plus 3x. So just kind of setting up our formula here, right? Where those y's are, I'm going to replace that with x squared plus 3x. And now my factors are actually trinomials again. So I'm going to see if I can factor these any further. So over here on the left, I would want to multiply to negative 10 and add to 3. So I'm going to do that using 5 and negative 2. So the trinomial on the left is going to factor down to x plus 5 times x minus 2. And then over here in my right factor, I would want to multiply to negative 4 and add to 3. I'm going to do that with positive 4 and negative 1. So the x squared plus 3x minus 4 on the right factors down to x plus 4 times x minus 1. So our fully factored equation from our original problem, right, we started up here with our original problem looking like this, and our final factored answer is these 4 linear terms.